Hey folks, and welcome to SOL Review Packet Week 11. Today we will look at regressions and combinatorics. So let's start off by looking at regression models. So we want to use a regression model when we are given a set of data and we want to make an equation. So we want to determine the relationship between the x and the y. We can also use regression models to make predictions about values that we don't have. When I'm given an x and I want to know the y, or I'm given a y and I want to know the x value. So we're going to use Desmos to help us with regression models today. And we can make linear regressions, quadratic regressions, and exponential regressions. What we need to memorize is the format for each regression for linear, quadratic, and exponential. These are not given to you on the SOL, so you need to memorize them. So let's start off with our first example. A scientist obtained a sample that contained 80 grams of radioactive barium-122 that decays exponentially over time. The amount of barium-122 that remained in the sample at the observed times is shown in the table. If the radioactive decay continues at the same rate, which is closest to the amount of the sample of barium-122 at 5 minutes? So what we want to do is create a regression model based on our data and then figure out the y value when our x is 5. So time is going to be x and our mass will be y. So the first thing we want to do is go to Desmos, hit the plus, add a table, and enter in our data. You can either use the keypad or you can use the keyboard on your computer. So let me do that. So now I've entered my data and I can look at my data points. If I was not given or told what type of regression I need to do, I would look at my data points to determine what would be the best fit model. But I was told in this problem that it's exponential, so I'm going to do an exponential regression. In line 2, we're going to type the format for an exponential regression. And you see our regression model going through our points. When you are doing an exponential regression, you need to click log mode. Enabling log mode is going to make it so Desmos calculates a regression the same exact way as a TI-84 calculator does. So make sure you click log mode if you are doing an exponential regression. So now we have our regression model through here, and we are asked what is the closest to the amount of the sample at 5 minutes. So our value that we are given is that x is equal to 5. So we are given x equals 5, and now I can look at my intersection of the line x equals 5 and our regression model, and I see it's at 5, 14.145. Looking at my answer choices, the closest answer choice is answer choice D. Let's look at our second example. The table below shows the value of a certain collectible baseball card over 8 years. Which exponential equation best represents the data? So I'm given my data points and I want to figure out what is the exponential equation. So the first thing I need to do is enter in my data points into line 1. So I'll clear out what I have, add a table, and go from there. So we've entered our data into line 1, and since we know we want to do an exponential regression, I can type in the format into line 2. And notice if I do not click on log mode, my A value and my B value do not match up with any of my answer choices. But if I click log mode, we can see that they do match up. So my A value is 2.25 and my base, my B value is 1.59, and that matches up with option J. Now let's take a look at combinatorics. We have three things we need to look at for combinatorics. The first is the fundamental counting principle that says if one decision can be made m ways and another decision can be made n ways, then the two decisions together can be made m times n ways. We also have permutations and combinations, which involve choosing a subset of a larger set. Permutations are used when the order that you are picking your items matter. Combinations are used when the order does not matter. Again, we can use Desmos to calculate permutations and combinations. Let's look at our first example. Maria bought a new bicycle lock. She must choose a code that consists of 3 digits. No digit can be used more than once. How many different 3-digit codes are possible? Well, if this is a bike lock, then I know that the order that I put the numbers in the lock matters, so this is going to be a permutation. Now, I want to choose a 3-digit code, and if it's 3 digits, I know I can use the numbers 0 through 9, so that's a total of 10. So I have 10 choices that I'm starting with, and I want a 3-digit code, and I want to choose 3 of them. So let's see how we enter this into Desmos. So I go to Desmos, I can go to one of my lines, hit the keypad, functions, stats, permutation, and I want 10, and I want to pick 3 of them, and there are 720 combinations. Our next example, a box contains 8 tiles, each a different color. Sally is going to select 2 tiles without replacement. How many different groups of 2 differently colored tiles could Sally choose? So there are 8 choices, and I want to pick 2 of them. But it doesn't specify that the order is important, so picking a red one and a blue one is the same as picking a blue one and a red one, because I still have a red and a blue when I take my group. So this is a combination. I have 8 total, and I want to choose 2 of them. So again, I can go into Desmos, go to functions, stats, and then a combination. I have 8, and I want to pick 2, and I'm given that that is 28. So there are 28 possible combinations. That's all for today. Have a great day.